Hello, welcome to Econometrics Melody. In this tutorial, we'll deal with regular expressions in Stata. Regular expressions are also the string functions. So let's begin. This is the usual Stata interface. With this main Stata interface active each time, press Ctrl 8 for activating data editor and Ctrl 9 for activating do file. These are the operators that we are going to use in this regular expressions. So this hyphen, this is used for matching a range of characters or numbers. This period, this is used to match any character, and this is used as a logical operator or, and this or this is used as an escape character to match characters that would otherwise be interpreted as a regular expression or operator. This is used as a set of allowable characters or expression to use in matching. Asterisk is used to match 0 or more of the preceding expressions. Plus is used to match one or more of the preceding expressions. This caret sign is used to match at the beginning of the string. Dollar is used to match at the end of the string. This question mark is used to match 0 or one of the previous expression. And these small brackets, these are used to extract the substrings. We'll make use of these three functions in a regular expression. So the initial 5 letters, this is the abbreviated form for regular expression. M for match, and the R is for replace, and the S is for substring. We'll reinforce the operators by the help of an example. So let's begin. Let us clear everything, and we generate a string variable using input and in command, and we compress this. Let's say about the operators, this big bracket and the hyphen. What does this do? So we generate a variable b equals to 1 if regular expression m for match. So in this variable, if we have a in any of the observations, then this will result 1 for that observation. This is as simple as Jonathan. What does this indicate? This indicates all of these 6 observations, they have a in it, and this observation does not have any a. Similarly, we generate a variable c if we have ab anywhere in the observations. So only this observation number 2 have ab. So where is that? This ab. So let us repeat the same process, but this time we include this operator, big bracket, and what happens? Let's see. So anything in between this, these are the allowable set of characters. So anywhere in the observations, if we have a or b, then this will return as true. So all the observations have either a or b or both. Let us generate another variable d. So it should have a hyphen b, exactly a hyphen b, then it results true, else it will result as missing value. And same only this observation number 5, it has exactly a hyphen b somewhere in this string. So this is a dash b, so this is true. Now let us write the same thing within the big bracket, and what does this indicate? If we have these characters, at least one of these characters anywhere in the observation, then this will replace the variable d with 1. So we have either a or hyphen or b in full observations. Let us go to another operator, this period or backslash. So what does this do? Let us drop bcd, and this period indicates any character, it matches any character, so the observations should have any 3 characters, but all the observations have at least 3 characters, so this is true for all observations. This is a part of the regular expression operator, but we are introducing here as a character, so there is a mismatch in understanding and it will result in an error. So if we want to introduce any regular expression operator as a character, then we need to make use of this slash, backslash. Now there is no confusion, and these observations, they have at least one opening big bracket. Let us come to asterisk and plus. What do they do? So we need to have d followed by 0 or more f. So D, F, F. So this is the true case, otherwise else it will be false. So these observations, they have at least D followed by 0 or more F. So if we replace this asterisk by plus, our interpretation would be, so all the observations that need to have D or at least one F, D followed by at least one F. So this observation have D followed by at least one F. What happens if we write H asterisk? So we may have 0 H or this pattern of H. So these observations follow this condition. They may not have H, or they may have at least one H. Now let us talk about the beginning and ending operator, caret and dollar respectively. The observation that begins with A, so this observation begins with A due to caret sign. The observation that ends with A, dollar, the observation that end with A. And let us interpret this, the observation that should begin with the observation that begins with yes and can have 0 or more number of letters followed by A. So let us see which observation does obey this condition. So this begins with yes, can have 0 or more letters followed by A. So this is it. So observation 3, due to case sensitivity of yes, we could not include this, but if you want to include this, you can specify this allowable characters. Either this should begin with either a small or capital letter S followed by 0 or more letters followed by A. So if we specify this condition, then we can include the third observation as well. And let us run this once again, and there you go. Just drop BSCD and try another variation. So in this expression, anything that begins with 0 yes or more number of S followed by A. So this is the pattern. This should be the pattern to be true, and we get the result. So only observation number 4 is true, that 0 S followed by A. This is true. We have S, but the immediate follower is not A. Therefore, other observations do not qualify. This is again very simple. Let us try another observation. So we have missing, what is the condition? It should begin with yes followed by 0 or more number of letters, and we have space 0 or more number of space followed by 0 or more number of letters, and it should end with Y. So none of the observation this ends with Y, but we have only one or more space in between two words, so this does not qualify. So only 2 words. So this has the probability of, observation number 7 has the probability of qualifying, but it is due to this asterisk. So let us adjust this. So had we written included asterisk here, this would be true. So let us run this once again. Let us write here replace instead of this, and if we run this, you see this is true. Only 2 letter word, because one space is here, and we have specified only one or more number of spaces in between these characters. Let's try this, and we have missing. So we have allowed it for 3 words, 1 space, 2 space, and 3 words. So it begins with yes followed by any number of letters followed by 0 or more spaces immediately followed by 0 or more letters followed by 0 or more spaces followed by 0 or more letters, and it should end with Y. So 3 letters, this and this, both they can qualify, but the obstacle is for the second observation, it is the big bracket that is disturbing us. So the position of big bracket is after the first space. So if we write this and include this both and any number of this, let's see whether we get the right result or not. See, we get that result 9 here. So by this time, I think you have understood this. These are the basic understanding of the operators. Then we make use of these operators and try the complex one. Not complex, but a little involving steps. Now let us drop BSCD. Let us use this OR operator. Okay, so what does this indicate? We want this to be included as a character, so we have at least one opening big bracket in this observations. Let us try this, and what does it say? We need to have exactly opening and closing big brackets, so only two observations qualify for this. So we need to have opening bracket followed by asterisk. So there is only one observation that satisfies this condition, opening bracket followed by asterisk. So it can have opening bracket, and this is or it can have closing bracket, or it can have asterisk. So what are those observations that satisfy this condition? So another, it can have both opening and closing bracket, or asterisk, or question mark. Should have both opening and closing bracket, you see. Both opening and closing bracket, question mark, both opening and closing bracket, asterisk. This is due to asterisk, not due to opening bracket, because we need to have both opening or closing bracket. This is true because of this asterisk, and here this is again true because of this asterisk. And the second, let us interpret the expression first. So this should have both opening and closing bracket, or asterisk, or question mark. We have nearly same condition, and this hyphen is new here. So let us execute this. So we're replacing D. Let us pay attention to D. So you see we have opening bracket, but it's not true because we need to have both opening and closing bracket. This is true, this is true because of this is true, and this is true because of this hyphen. We have included hyphen also. It's a character, and this is true because of this asterisk, and this is true because of this asterisk. We have explained the use of regular expression operators. After this, we are going to employ this and see the results. Let us drop bcd first, and then generate variable b that is equal to name, and let us replace in this variable that matches this pattern by God. This is the first word because we have not specified a space in it, so only the first word is replaced by God. Now let us try this if we provide the space in it, and let's see what happens to this. Now let us drop b, and again generate a variable b that is equal to name, and let us try to clean this data. So what is this expression? We are searching opening bracket or closing bracket, or both opening and closing bracket, or asterisk, or question mark, or hyphen, and we are replacing it with nothing. In fact, we are simply removing that. Now we are going to again repeat this process because only the initial signs were replaced. Now let us again run this once again, and you see we have removed all these symbols or signs. Now we want to remove all the leading, trailing, and intermediate spaces in between them, and we got, and let us make it a fine standard variable, and see we have cleaned the variable name. Let us make use of this regular expression. These initial 5 letters are common, so yes for substring. Let us extract some substring. Let us make use of this function. Let us drop name and rename b as name. This is our fine data. Let us compress it, and let us change the format and align it towards left. 0 indicates whatever we have is our expression, that is the default one. Let us see by the help of example. So this extracts only the first word. Now let us format it and align it towards left. Now we are going to make use of this small brackets, if you notice it. So this is going to position it. This expression within this small bracket is termed as 1 for the substring, and this will be 2, another set of small bracket. So if you want to extract anything that matches this expression, so you will have to refer 1 over here. And if you want to extract anything that matches the second expression or within the second bracket, a small bracket, then you need to specify 2. So it matches number of substrings, and we want to refer the number of the particular substring that is of our choice. So let us see, we have specified 2. So these are the patterns we have specified. So this basically, this represents the first word space, and this represents the second word, and we are going to extract the second word here. So let us see what is the second word in our variable name. So these are the second words. Let us give it a fine formatting, and we get this format. Let us extract the last name. So we specify 2 space, and at the extreme we have this letters or more letters, 1 or more letters. So these are the words. So we are going to extract the last name. So this is going to be the last name. So let us run this. By this time, this expression is very simple and easy. Format day, and this is A. Did you get the value of E? Drop B, C, D, E, and directly use this expression. So we are extracting the third expression, a space in between, second expression, a space in between, and the first expression. We are reversing the order, right? Format this, and if there is any space in between, leading, trailing, or intermediate space, where. So if you compare the variable name and B, they are in their reverse form. I mean, the position of the word, they are in their reverse form. Now let us see some of the examples, and let us do it really very quick. And what are we going to do with the prefix of RESS? It can be any composition of letters or no letter. So we are going to replace it by address. So we are going to, RESS is common in all the observation, and we are going to replace it by address, and let us see what happens. Let us try another example, and in this example let us see the expression. So M for match, all the expressions are for match. So this matches this expression. If the observation of ID begins with 0 and 1, we categorize it by 1. If it begins with 2 followed by any letter, we categorize it by 2. If it begins with 2 followed by any number, we categorize it by 3. If it begins with 3 and followed by any letters, we categorize it by 4. Begins with 3 followed by a number, we categorize it by 5. Begins with 4 followed by a letter, we categorize it by 6. Begins with 4 followed by a number, we categorize it by 7. Let's see how does this work. We'll make a separate video on labeling variables, but still this should be clear. And let us align and let us sort this. Let's try another example, and let us see what does it do. So we're going to again categorize this based on the repeating numbers. So in regular expression, 0 to 9 is only allowed. So if you write 0 to 100, it does not make any sense. Only 0 to 9 is the permissible range. This will create a categorical variable based on different repeating numbers. Now let us move to another example. So let us say these are the social security code number or any hypothetical bank account number. So the first initial 2 digits represent date, initial following 2 digits represent month, and then after 2 digits represent year. So how do we extract the date of birth from this hypothetical data? So let us run this really very quick and run this expression. So we'll generate a variable dmy using this expression, and this is our regular expression. We extract the initial 6 digits, and after we use this date function, date and time function, and we specify to this function that the order is in the form date, month, and year. So this is the 2 digits year, and it will handle it properly. And we provide the appropriate date and time format. Let us move to another example. This is the case wherein we want to extract these 5 digits, ending 5 digits. So how do we do this? Let's say this is a zip code. We want to generate a zip code out of this ending 5-digit numbers. So though there are beginning numbers as well, seven digits I guess, but we want only this ending 5-digit number. So this is our expression. So we take the 2, 3, 4, 5. So we keep this 5 digits within a small bracket so that it will be easy for us to extract and refer this h1 as you see here. Then after we write this expression, we take the 5-digit number, then after we allow for hyphen, any number of hyphens, then after we allow for any number of species, we allow for any number of digits, then after we allow for any number of letters, but we extract only these 5 numbers. So this is our ending match. Okay, so let us say this is very simple. We have gone through this and we get our result. So this is the zip code. So another example, let us say you have this data during a survey. You asked this question: since last 3 months, how many days have you woken up before 4 a.m.? And if you get the answer in this format, now you need to clean this data. So let us clean this really very quick. First of all, we generate a variable a using the real function. Then after we replace this never and never, it's 0. So this is very simple, and we use this expression. Please, I hope you can understand this by now. And let us again replace this 20 days and 20 days plus to 20. So let us do this. After this, we replace this always and every day age 90, because it's a range of 3 months, and we express this 90 and this plus sign, 10 plus sign, to be 10, and then 500 days, it's to be 500 for the time being, and later we'll replace this to be missing because, or as an outlier, because the question is limited to 3 months, so the maximum value is 90. Then after we replace this range 18 to 30 to 18, and 17 to 40 is 17. So if you see the expression, this is where this 2, and here we, in the previous one, we had allowed it for the hyphen, and we separate it into these small brackets, and we reference the number. So this is very simple by now. And let us replace this 9099H missing value, and then finally let us replace this outlier by missing value. So this is our point data for analysis. Okay, now let us go to our last example. So this is the data, and let us use the regular expression to extract the day, extract the month, and extract the year. So if you see the year, they are not uniform. They are somewhere it's 4 digits, somewhere it's 2 digits. And how do we handle this? So any number greater than 21, we want to specify the century as 19th century, and any number that is less than or equal to 21, we want to specify it is 20th century. Then after we generate a variable by, if they are the string, we can use plus to add them, and we get our day, month, and year. So this is it. Then after Let us drop the day, month, and year. We see this relationship. So this is the same string, but we have adjusted for the 4 digits here. Now let us use our date and time function to manipulate this and provide a format. This is one way, and another alternative way is to use this function reference. Let's just use day emy and generate this function. And finally, let us order this and let us compress if possible. So how is this different? We did date 1 by using this our input, and emy1 by using this find variable, this find or refine data. So hope you have understood this. Please take your time in understanding this. Thank you very much for your time. Econometrics Melody.